Okay, so welcome. So in this video, we are going to solve a problem here. Okay, so the question reads, use the node voltage method to find V1, V2, and V3 in the circuit below. And then also we have to find how much power the 40-volt voltage source delivers to the circuit. Okay, so this problem now we've been restricted what method we are supposed to use or what method we're supposed to apply. Okay, so we have been told that we have to use node voltage method or we call it what? Node analysis, isn't it? So we're going to use node analysis to solve this problem. Okay, so remember that when you are using node analysis, the first thing you need to find or maybe to count, you need to count the number of nodes that are there, isn't it? Okay, so you see our circuit here has got a couple of nodes, so let's count them together. So remember that a node is a point where two or more elements are connected. So this is a node, right? I'll call this node number one. Okay, this is a node. I'll call this node number two. This whole thing again is a node. I'll call this node number three. Okay, and then this is a node. I'll call this node number four. This is a node. I'll call this node number five. Even here, you can call this a node again as node number six. We have so many nodes here, isn't it? Okay, there are a lot. So if we are to solve for the voltages that are known, we need to have six voltages, right? Okay, but we from these nodes that we've counted, we need also to identify which one will be our reference node. So a reference node is a node that we're going to give a potential of 0 volts. Okay. So now we can make any node as a reference node, but most of the times choose the node that has a maximum number of elements connected to it. Okay, it's very easy. All right. Now, for example, if I make this as my reference node, for example, right? If you remember very well, if there's a voltage source that is not attached to a reference node, okay, if that voltage source is not attached to the reference node, that voltage source forms what we call a supernode, right? Okay, so in this video, I'm trying to avoid the issue of supernodes because I'm going to talk about that separately in the other video. So for now, let us avoid the issue of supernode. So since if I pick this one as my reference node to give it a 0 volts, this voltage source here is going to form a supernode, isn't it? So I'm trying to avoid that. So what I'm going to do here, if you notice 3 ohm resistor and 1 ohm resistor, these two are in series. So I'm going to combine this 1 and the 3 to form one resistor. They're in series, as you can see, same current to pass through them. Okay, so let me just redraw the circuit. Let me try to redraw the circuit. So I'll redraw the circuit. Okay, let me use y is white. Y is white. Okay, here you are. So I'll redraw the circuit. This is a voltage source here. Okay, from this voltage source, I need the resistor there, right? So this resistor I'm going to put here is a combination of what? 1 ohm resistor and a 3 ohm resistor. And here again there's another resistor. Okay? And then here we have no resistor. That 1 ohm will combine with the 3 ohm to form one resistor. Okay? And then here there's another resistor. Okay, here there's a resistor. Okay? And here again there's another resistor. Okay, and then here we have a dependent independent current source, right? We have an independent current source there. Okay. Okay. So this is a positive way minus, and this is a 40 volts of 40 volt source, and then there's a resistor here. This resistor now is a combination of 1 and 3. So this makes 4 ohm resistor, right? And then there's another resistor here, which you call this 40 ohm resistor. And then there's another resistor here, which is what? A 2 ohm resistor. And there's another resistor here, a 4 ohm resistor. And then you have another resistor here, which is what? A 2 ohm resistor. And then this is a current source. You have a current in that direction, right? And that is 2080 amp current source. Okay, now we have to find these voltages. So we have the voltage here, which is V1. Okay, we have to find this voltage across the 4 ohm resistor. It's called V1. We also have the voltage across the 4 ohm resistor. This one is called V2, right? And then also another voltage across the 2 ohm resistor is called V3. And the signs, we have to pay attention to their signs as well. This one is positive up there, negative down. This one is negative this side here, positive this side, right? Okay, and then here obviously this is positive here, this is negative there. Okay, all right. Now what's the next thing? Now since this one of I send this guy as a what, a reference node, right? So we're going to make this guy as a reference node. So as you can see, upon making this one as a reference node, then this one no longer becomes what, a super node. Okay, because of the resistor that was in between, it was initially a super node. Now because we have removed that resistor and combined with the 3 ohm resistor, this 40 ohm 40 volts source is not doesn't become a super node, right? Okay, when we make this one as a reference node. Okay, as you can see, it's attached to the what, to the reference node. So a voltage source which is attached to the reference node doesn't form a super node. Okay, all right, now it means that now I have how many nodes? So you notice that if this 40 volts is attached to the ground here, it means that even the voltage at this point here will also be 40 volts. So at this point here, we know the voltage. So as you can see, we've reduced the number of nodes, right? I mean, and the nodes with unknown voltages. So this one also be 40 volts because the end of the 40 volts is attached to the ground. It's not attached to the resistor or something. So even this point also be at 40 volts potential. Okay, now let us label the other points. Let us label the other points. Okay, so the other points, this one will be, I'll call this VA, right? I'll call this VB, and I'll call this VC, that node there. Okay, and then once you label the nodes, what is the next thing? Okay, what did you talk about last time? The next thing we need to do is what? Assign the current sign. So at this node, node A, I'm going to have current in that direction, another current in this direction, okay, away from the node. Okay, also at node B, I'm going to have current in this direction, another current in that direction, another current in that direction, right? Next, node C, okay, what color should I use? Okay, node C, I'm going to have current in that direction, current in that direction, and another current in this direction. Okay, all right. So now let us see apply case. So I'm going to call this current as node A, this one as I1, right? I'll call this I2, I'll call this I3, and then at this node I'll call this I4, I'll call this I5, this one will be I6, right? And then at this node, this one I'll call it I7, this one will be I8, and then I9. Okay, so I have 9 currents there, right? Those non-reference nodes. Okay, so now let us apply KCL at node VA. Okay, so KCL there to be IA, I1, sorry, plus I2 plus I3 equal to 0. Okay, all right, now we have to write I1 in terms of the voltages, right? Remember that, see that I1 is coming from VA going to 40, right? So I1 is going to be VA minus 40 divided by the resistor, which is 4 ohms, right? Across that path. Okay, I'll just write 4. And then what about I2? I2 is coming from VA to the ground, right? So this is a ground that's zero potential. So this will be VA minus 0, just be VA divided by 40, the resistor across it, okay? And then I3 is coming from VA to VB. As you can see the direction there. So this will be VA minus VB divided by the resistor across that path, which is 2 ohms, okay? And this is equal to 0. So at this point, I'm going to multiply, okay, by the lowest common multiple 4, 2, and 40, which is 40 itself, okay? Which is 40 itself. I multiply the equation by 40. So 4 into 4, that is 10, right? So 10 by the numerator there, you have 10 times VA minus 40, and then plus this is VA over 40 times 40, that's just VA, plus this is VA minus VB, okay? And then if over 20 times, over 2 times 20 times 40, that is 20, right? So I have 20 outside here, multiply by that, right? And this is equal to 0, okay? And then this is 10 VA minus 400, right? Plus VA plus 20 VA minus 20 VB. This is equal to 0, okay? Now let us combine like terms. 10 plus 1 plus 20, that is 31 VA, okay? And then minus 20 VB. This is equal to 400, right? Taking 400 the other side of the equation. So I'll call this equation number 1, okay? So we're done with the node number 1, where there's VA. Let's go to VB. So VB, as you can see, we apply KCL there again. So I'm going to erase this part. So at that node, we apply KCL. So you see that we have I4 plus I5 plus I6 equal to 0, okay? So how can you write I4 in terms of voltage? So I4 is from VB to VA. So this will be VB minus VA divided by the resistor, which is 2 ohms, plus I5. I5 is VB minus VC. As you can see, it's going down there, right? So this will be VB minus VC divided by the resistor there, which is 4 ohms, plus what about I6? You see that I6 is same as 28 amps, but in the opposite direction of it, right? So I6 should be negative 28 amps, okay? So this will be negative 28 amps, and this is equal to 0. Okay, now let us multiply again by the lowest common multiple of what? 2 and 4, which is 4 itself, right? Okay, so multiply the whole equation by 4. So VB minus VA over 2 by 4. 2 into 4, it's what? 2 times, right? So this will be 2 multiplied by VB minus VA plus VB minus VC over 4 by 4. So 4 and 4 cancel out, just leaving behind VB minus VC. And then minus 28 by 4. So this is 112. Okay, you just move this equation. We take it somewhere. We just take it here, right? Or let me take it down here. Okay, so this becomes 2VB, sorry, 2VB minus 2VA plus VB minus VC equal to 112. So we write them in order. I'll start with negative I'll start with negative 2VA, and then I'll write B terms, which is a plus 3B, right? 3VB, because 2VB and the positive 1VB there make 3VB, and then minus VC equal to 112, right? So this will be the second equation. So our second equation now be what? negative 2VA plus 3VB minus VC is equal to 112. Okay, let us write the last equation at the last node. Okay, at the last node there. So you see that you have I7, I8 plus I9. Okay, I7 plus I8 plus I9 equal to 0. So let us also apply the Ohm's law. So we write the I7, I8, and I9 in terms of what? In terms of the voltages. So I7 is from VC to what? To 0, isn't it? So the VC minus 0 over 2, right? So that's just be VC over 2. I8 is VC minus VB divided by 4. Okay, VC minus VB divided by 4 plus I9. As you can see, I9 is the same current, uses 28 amps, right? It's the same path. So you have just 28 amps, and this is equal to 0. Okay, and then let us multiply by the common lowest common multiple of 2 and 4, which is 4. Okay, so VC over 2 times 4, that is just 2VC, right? Plus 4 and 4 cancel, just remaining with VC minus VB plus 4 by 28, that is 112, and this is equal to 0. Okay, so here we have 3VC minus VB equal to 112, negative, right? Because when it moves outside, you have negative. So that's our third equation. So we have 3VC minus VB equal to negative 112. Okay. So now we need to solve these equations. Right? This is our second equation, this is our third equation. So I have three equations now. So we need to solve them. I don't know which method we're going to use. Okay, so I can use elimination method, okay, or I can use a substitution method. It's up. Let me try substitution method because I can see that the last equation there I can just make VB the subject. So VB the subject there, I'll take the VB the other side of the equation, wow, negative 112 to the other side of the equation, right? So this becomes VB is equal to 3VC plus 112, right? Okay, so let us substitute wherever there is VB in these other two equations. So from equation number 1, we have 331 minus 20, this 21 VA, sorry, 21 VA minus 20 VB, which is a 3VC plus 112 equal to 400. So let us simplify this. So this is the 31 VA, not 31, not 3 VA, 31 VA minus 60 VC. Okay, what is negative 20 by 112? So negative 20 by 112, this is equal to negative 240, right? Minus 240 equal to 400. Okay, so if I take negative 240, that's out of the equation, you add them. So you have 31 VA minus 60 VC equal to so this one I was supposed to call it equation number 4. The one I made the subject formula, and then this will be equal to what? So 400 plus 2240. This is 2640. So I'll call this equation number 5, right? Okay, and then I also have substitute VB in the other equation, which is equation number 2. So minus 2A, 2VA plus 3VB minus your VC here. What is VC? Oh, actually VB is there, right? It's one we're supposed to substitute. 3VB. Our VB is simply 3 VC plus 112, and then minus VC equal to 1 1. Okay, this is equal to what? 1 1 2, right? Yes, 1 1 2. So let us simplify. We have negative 2VA. This is 9VC minus VC, that's plus 8VC, right? And then 112 by 3. 112 by 3. That is 336. So 336, go the other side, we're going to have 112 minus 336. So 112 minus 336. You have negative 224 here. Okay, so this is equation number 6. I'll call this equation number 6. So you can now solve equation number 5 and equation number 6, right? Okay. Okay, so which method can I use here to solve this? So what I'm going to do, I can divide again the first equation by 2 throughout, right? So the first equation actually, I mean, because it's reducible, I think. So I'm going to have negative VA. This is just math. Okay, I'll divide by negative 2 in short. Okay, so I'll divide by negative 2. So I have VA minus 4VC equal to, okay, so that get divided by negative 2, you have negative 112, right? Or positive 112, sorry. Okay, and then meaning that our VA becomes what? 112 plus 4VC. And then I'll get this guy and substitute in this other equation so that I can just remain with what? VC alone. Okay, so I'm just using substitution method here. VA, in place of VA, I'll put what? 112 plus 4VC minus 60VC equal to 2640, right? Okay, so let us simplify. So this will be 31 by 112, 31 by 112. This is 34, 3472, and then 31 by 4, that's 1.4, minus 60VC equal to 2640, right? Okay, and then let us simplify again. 124 minus 60, you have 64 VC, right? So this 64 VC equal to, so this minus that, okay, 2640 minus 3472, that's negative 882, right? So 882 divided by 64, so VC is equal to negative 13, okay, volts. Okay, so VC is negative 13 volts. Now from VC, we can find VA, right? Since they're rated by that equation there. So VA will be equal to 112 plus 4VC, right? 4 by negative 13. So this is what? 112 plus 4 by negative 13. Okay, that is 60 volts. Okay, so 60 volts. And then we can also find what? VB. VB using this relationship here. So the VB is equal to 3VC plus 112. VB is equal to 3VC plus 112. So VB is equal to 3. VC is negative 13 plus 112. 3 by negative 13 plus 112. So this is 73 volts. Okay, now the question is not asking us to find VB, whatever. It's asking us to find V1, V2, and V3, isn't it? Okay, so how do we find V1 now? Okay, so V1 has, V1 has to be rated to these other voltages, right? So V1, as you can see, is a voltage across what? The 40 ohm resistor. So V1 can be calculated as what? The difference between these 2 points. Okay, so this is VA minus 0. So you can say that let's say you want to subtract with respect to this node, right? To this VA. So this is same as what? VA minus what voltage is here? 0, right? Is equal to V1. Why am I equating positive V1 and not negative? It's because if you're coming from here, you equate it to the sign that you meet first, okay? So VA minus this voltage here is equal to positive V1 because I meet the positive sign first, okay? So be careful that one. So this is equal to V1, right? So you can say V1 is same as what? VA. So V1 is equal to VA. And what was our VA value? The VA value was equal to, what was VA? Okay, where is VA? Where is VE? I can't see VA. Where is it? Oh, here it is, right? So VA was equal to 60. So our V1 is simply equal to 60 volts. Okay, 60 volts. Okay, and then we can also find V2. So how can we find V2? The same concept. If we come from this node VB to VC, so VB minus VC is equal to what sign do you meet first as we're coming from VB? You're meeting positive sign, right? So it's equal to positive V2, right? Okay, so V2 is simply VB minus VC. So what is our VB? Oh, our VB was 73, VC was negative 13. So 73 minus negative 13. So this is 86 volts, right? So this is 86 volts as V2. And then we can also calculate what? VC. So VC, if you come from the node VC itself, right? What do you have? So VC minus the where you are going, right? Okay, because the voltage you're trying to find is V3, not VC, sorry, V3. So VC minus that voltage where you're going, the end point, which is 0, is equal to V3, right? Positive V3, right? Because we're meeting the positive sign first. So V3 is equal to VC, and our VC was negative 13 volts. So our V3 is simply negative 13 volts. So this is the end of our presentation. Now, there's something I think we can also check MATLAB. Let's confirm if the answer is correct, right? So what I'm going to do, this is MATLAB. I'm going to get a voltage source. Okay, voltage source is a DC voltage source. Okay, let's see if our answers make sense, right? And then I'm also going to get the resistor. So I'm going to get the RL. I'll convert to resistor. Okay, so how many do we have? So I can control copy and paste each one of them, and then I'll connect them later on. Okay, so here they were the resistance of 5 ohms. Okay, I just want to confirm, and then I'll rotate this. Okay, the resistance of I don't know how much this one was, and then here, okay, this one also had a resistor here. Okay, a resistor here, and then here also had another resistor, right? So this MATLAB Simulink can build a circuit, and then here again we had another resistor. Now what I'm going to do here is that instead of me using the current source which is there, I'm going to use source transformation. See, these guys are in parallel to each other, right? So I can use source transformation and convert this guy to a voltage. So if the current and the resistor in parallel, can convert to a voltage by using source transformation, right? So I'm going to multiply 28 by 4. That's the voltage I'm going to write there as 112. Okay, so 112 volts, right? So I need 104 volts in series. So I'm going to connect them in series once I use source transformation, right? So I can put these guys in series. I need another voltage source here. Okay, so for now, let me just do this. I'll pull this down so it becomes bigger, right? Okay, so I'll put this voltage source here. Okay. Okay, now convert all these guys to resistors. So R, what value of the resistor? This one was 5 ohms. Okay, and then this one was 40 ohms. It's a resistor as well, so I'll convert this guy to R. This was 40 ohms. Okay, and then one also was a resistor here. This was how much? Was it 2 ohms, I think? Yeah, 2 ohms. So it's a resistor. R, 2 ohms. Apply. Okay. And then we also have this, also as a resistor of how much value. Okay, so this resistor had a value of what was it? This was 4 ohms, I think. Yeah, 4 ohms. Apply. Okay. This is a resistor again, had a value of no, this one was 2 ohms, they're not 4 ohms, sorry. But this one is on at 4 ohms, which was 4 ohm resistor. Okay, so this is 4 ohms. Okay, so it's 4 ohms. This one is supposed to be 2 ohm resistor. So this is a 2 ohm resistor here. Yeah, I think. Yep. So this is a 2 ohm resistor. Okay, now remember you said this resistor and it was a biotech kind source, right? So I've used what called source transformation. So source transformation, so I can be able to use what the voltage source instead of DC. Okay. All right. So when you use source transformation, you can easily connect your resistor and the transform the current source, I mean voltage source to in series. So you can put them in series, right? So if you have a resistor and a current in parallel, you can use source transformation to convert that current source to what? To voltage source, and then the end result will be series. Okay, so those two components will be put in series. All right. So now let's put the voltages. This voltage was 40 volts. Okay. This is 40 volts voltage source. And then here, after we did the source transformation, this is 112 volts. Okay. Remember, 4 ohm resistor that was here, that is here, and then the current that was there as current source, 4 by 20, that is 1 4. Okay, now we need the what we call power going for this circuit to run. Okay, so just have to put it somewhere here. Okay, and then now we need to measure the current. So I need to get what we call voltage measurement. Okay, so measure the voltage. So remember that there are 3 voltages in measure, right? So I'll say control copy, control V, and then V, right? I can just paste them. So I need to measure the voltage across this resistor here. Okay. I need to measure the voltage across this resistor here. Okay. So remember, when you're measuring the voltage, you put your what? Your voltmeter parallel, right? Okay. And then even this guy here, remember for this resistor, you see that sign, the positive sign was to the right, right? Or the negative sign was to the left. So I need to make sure that you connect that way. Okay. So this is a positive sign. Okay, this is a negative sign. And then which other voltage are we measuring? We're supposed to measure this voltage, right? Which is across this form, from the top node to the bottom here, okay? From the top to the bottom there, okay? So I'm going to measure the same way here, okay? From the top to the bottom here, okay? That's the overall voltage, right? So from here to here. Okay, and then now to see the results, I need to use what we call a display, okay? So display, so this one is going to show the result, right? Of that voltage. I also need another display here, so I'll just, sorry. I need to copy. So Control C, Control V. So again, here, this guy has to show me the value. Okay, and then Control V again, even here, it has to show me the value, right? Okay, now my circuit is ready. I can actually run it so that I can confirm the values that I found. Theoretical values are the ones we found when solving, and also if we run MATLAB, the circuit, is it going to give us the same values? Okay, so let's see. So I'm going to run. Okay, did I change anything? Let me see, is everything okay? It's a 40 ohm. This is a 5 ohm resistor, right? This is a 2 ohm resistor. This is a 4 ohm resistor. Okay, This is a 112, right? That is 4 by 8. That is 112, okay? This is a 40-volt source. Okay, so it seems like it's giving us that. Let's take it back to oh, actually this was supposed to be 4, not 5. So sorry. Because remember we're adding 3. Okay, we're adding 3, 1 and 3, right? So it's supposed to make 4. So yes. I'm surprised why it's, yeah, had put 5 here. This resistor was 5. That was supposed to be 4, not 5. Let me run it again. Okay, so now as you can see, we are getting exact values, right? That we're supposed to. We had gotten when we are doing calculation. This voltage here was V1, this was V2 as negative 13, this is the V3 as what? As it 86 volts. So we're just using it to confirm our solution. So now having found the voltages, remember the second part of the question is asking us to find the power. How much power does the 40 volts voltage source deliver to the circuit? Okay, so we need to find the power the 40 voltage source delivers to the circuit. So how do we calculate that? Okay, so let's see. Okay, so let us see how much power that voltage source is delivering to the circuit. Okay, so I'm going to get rid of this here, bearing in mind that we've calculated those things. Okay, so just have to remember them because we're going to use them to find that. Okay, so to find the power that the voltage 40 voltage source is delivering, what you need to do is simply to find the current through that branch for the 40 voltage source, right? Okay, 40 volts. So how do you find the current here? Okay, so we can actually find the current since you know I1. What was I1? I1 was simply equal to what? VA minus V minus 40, right? That's how we found I1 minus 40 divided by the resistor, right? Divided by the resistor, which is 4 ohms, right? So what was VA? We found VA to be 60 volts, right? So let us substitute that. So I1 will be equal to 60 minus 40 divided by what? Divided by 4. Okay. So this is 60 minus 40. That is 20 divided by 4. So 5 amps current, right? Through that branch in that direction. Because we are getting a positive value. So it means the current is actually moving in that direction. Okay, is entering this source, right? So it's more like this voltage source is absorbing the current, it's absorbing power in short, not so it's power being absorbed by this element here. Okay, all right, now you know that power is simply the product of voltage times current, right? So the voltage is simply 40 volts, and then the current through it is 5 amps. So this gives us 200 watts power absorbed by this element, it's positive power. Okay. All right, let us also confirm this using MATLAB Simulink. Let's find the power here. So the power here can be found by, we need to measure the voltage and as well as the current through it, right? So let us get the voltage measurement. Okay, voltage measurement and also the current measurement, right? So current is simply, remember the current is connected in series, right? So I'm going to put the current element here. So I'm going to search for current measurement. Okay, for, of course, DC current. So this is element that measures current, right? Okay, so I'm going to rotate it like this. Okay, so connect this to the positive side and then the other negative side here, right? Okay, and then we also need to measure the voltage across it, right? So I'm going to rotate this, or let me just flip format, flip block, left, right, right, up, down, I think, format, flip block, up, down. Anyway, let me just flip left, right. Okay. No, it's okay like this because I need to connect the positive terminal here, right? So this is a positive terminal. Okay, it's easy to connect there. So I need to do something, right? Okay, let me do this. Okay, okay, and then the negative terminal there. And then now we need to get what we call, remember that power is the product of voltage and current, right? So I'm going to get this guy called the product, right? So this product is going to multiply the two. Okay, so it's going to multiply the voltage as well as the current, right? And then from this, I need a display, right? So that I can see the value of the product of the two. Okay, we rotate it that direction. Okay, now I can run my circuit. Okay, so as you can see, it's giving me negative 200 volts. I mean watts, right? The reason being is that this current source has been flipped. Okay, remember the current is actually moving this direction, right? So if we change the direction, this current source is going to give us positive. Remember the current is actually moving in this direction, opposite direction. So no wonder we have negative 200 here. Okay, the current is moving in the other way. When we measure the way we put the, I mean, when we put the ammeter the way it is here, it means the current is actually moving from positive going up there, or it's moving from negative terminal entering to the positive of it, isn't it? So since I put it like we flipped it, now we're getting negative 200 amps. Okay, so this marks the end of our discussion. Thank you so much for your time and your patience, of course. Don't forget to subscribe.